12:15, it doesn't mean that 12:15. It doesn't mean that 12:15, then only you ask for consent to join the group. Means that's like 12:15, we're already ready and we're going to start now. Okay, so I've actually given you like a set of questions for you to attempt if you actually did. It's actually on chapter 2, so which is on confidence intervals. So I actually put together a bunch of previous test question so that we can actually discuss different scenario, because for confidence interval, so there are actually a lot of formulas. So as you can see in your statistical table, so there are a lot of things that you have to be familiar with in terms of the formula and the scenario. But the good news is that once you understand like how to use the formula and how do you construct confidence interval for like one problem, so you will be able to get the idea for the rest of them as well. Okay, so today what I'm going to do is, so we're going to start discussing the problem. So I'm going to start with question number 3. So read the question first. So it says over here, the manager of a vehicle company is testing 2 brands of radial tires. So we have 2 brands of tires and assign 1 tire of each brand at random to the 2 rear wheels of 8 cars. So we have 8 cars and we're going to assign each brand at random to the rear wheels, rear mean behind, of 8 cars, and run the car until the tires worn out. So the distance traveled are as follows, random to the 2 rear wheels of 8 cars. Okay, so basically we have 2 brands and we wanted to test both of the brand, and we test both of them on the same car. So we have 8 together, 1, 2, 3, 4, 5, 6, 7, and also 8. So if you notice over here, we have 2 populations, not 2 populations, we have 2 data that we actually collected. So we have data that we collected from brand 1, and we also have the data that we collected from brand 2. And if you read the question, it says find a 94% confidence interval to estimate the mean difference. So this is going to be the keyword that you should be looking for this case. So 95% confidence interval to estimate the mean difference in distance travel for both brands of tire. Okay, so now we're going to talk about confidence interval for mean difference. Okay, however, for the case of mean, there are going to be 3 cases. So let me add a blank page. So 1 is going to be the 1 population mean. So 1 population mean, okay, and the other is going to be concerning about 2 population means. So for the case of 2 populations mean, so we have 2 scenarios when it comes to the data. First, it could be dependent sample, and the other one is going to be the opposite, which is called as independent sample. Okay, so what is the difference between dependent and independent sample? So what happened is that, okay, let's talk about the similarity first. So the similarity is that, so both of them, so we are going to take 2 data. So for independent, the case of dependent, so we're going to have 2 data. And for the case of independent, we're also going to have 2 data. And what is going to be the difference between them? So the difference between them is that for the case of dependent, so what you do is that you take the data twice from the same sample. Okay, so meaning that from the same sample, from the same person or from the same car, so you take the data twice. So the easiest example of this is going to be when people go on a diet. So you know Khairul Amin, right? So he's very famous, Insta famous. He's an Insta famous, and he's going on a diet right now. So I'm going to give that an example. Okay, what happened is that, okay, let's say I'm a diet coach. So if you go on Instagram these days, there are a lot of people offering to coach you to lose your weight. Okay, I'm a diet coach and I'm coaching like 5 people. So this is going to be client number 1, so client number 2, client number 3, client number 4, and client number 5. So if I want to check the effectiveness of me being a coach, a diet coach, what I can do is I can take their weight before and also after. For example, the first person, so before he goes on the diet, he's 60.6, and after he goes on the diet, he become 55.8. So that is going to be an example. So the main point is that, so it's going to be dependent sample is from the same person. So you take the data twice. So that is called as being the dependent sample. Okay, and the other one is going to be the independent sample. So what is the difference between for the case of independent sample? So meaning that we have two different population. Right? For example, if I wanted to know how much time do UMP students spend on playing online games, for example, so like the title that you have for your assignment. So what I can do is I can have two different population. One is UMP students in Gambang. So the other population is going to be still the UMP student, but these people will be in Pekan. So these two people, they are not related to each other. So this UMP Gambang, so I will get some data. From UMP Pekan, I will get some data. So this will be the case of independent sample. Okay, so basically, again, I will repeat, dependent means from the same person, I took the data twice. And for the case of independent, I have two different population and I take the sample separately. Okay, so that is the difference between independent and dependent. Okay, now can somebody tell me, for the case that we have over here, sorry, it's referring to this one. For the case that we have over here about the car, is this dependent or independent sample?
Independent sample.
Independent sample.
Why is it, Shafiq? Dependent or independent?
Independent. Independent.
Okay, so that's right. So it is actually dependent sample. Why is it dependent? Because we have one population only. So the population will be the car. And from the same car, so we take the data twice. So we take the data when the car used brand 1, and we take the data when the car used brand 2. So it's basically the same idea as diet just now. So what happened before and after. But now it's going to be what happened when the car wear brand 1 and what happened when the car wear brand 2. So basically, so it's from the same car, we are taking two data. So that is going to be the case of dependent sample. And another hint that this is going to be dependent sample is going to be this word, mean difference. So when we talk about dependent sample, so we're going to use the term mean difference because the symbol that we use is going to be mu d. And for the case of independent sample, we use the term difference in means, so which is going to be mu1 minus mu2, right? So that will be a hint of whether this is going to be dependent or independent sample. And this question is actually very straightforward. It tells you right away that we wanted a mean difference. And for the case of independent sample, so what happened is that we're not going to analyze the data based on what given over here, but as it suggested, so this is going to be in terms of mu d. So what does d mean? So d is actually the difference. So our analysis, whether we're going to calculate mean or whether we're going to calculate standard deviation, so it's going to be on the difference. So how do we calculate the difference? So I'm going to put another row right here. So I'm going to calculate the difference. But how do I know whether it's going to be brand 1 minus brand 2 or brand 2 minus brand 1? First, I'm going to have a look at the question. So whether or not it actually mentions, so which brand comes first. And for this case, it doesn't mention whether it should be brand 1 minus brand 2 or brand 2 minus brand 1. So therefore, what we will do is we're going to refer to the data itself. I have brand 1 at the top, brand 2 at the bottom. So I'm going to take brand 1 minus brand 2. So I'm going to define over here that my difference is going to be data from brand 1 minus the data from brand 2. So you calculate each of them. So 45 minus 39. What is 45 minus 39, by the way? It's going to be 6, isn't it? Okay, so when I calculated the difference, I will get the first one is going to be a difference of 6. Here will be a difference of 3. This will be a difference of 1. This will be a difference of negative. So even if it's negative, then simply put negative. This is going to be a difference of 8. And this is going to be 4. This is going to be negative 1. And this is going to be negative 2. Even if the difference is going to be 0, so please put 0. Because 0, even if there is a 0 in your data, it should be there. You cannot simply, just because it's 0, you just don't write anything about it. No, it should be there as well. Okay, so now what we're going to do is we're going to use the formula. So you're going to go through here. So where is the formula for the case of dependent sample? So we are actually referring to mu d for this case. So where is the formula for mu d? So if you have a look at the confidence interval, it's written up here. So this is going to be for mean. This is mu1 minus mu2. So which is the case of independent. But now for our case, it's going to be this one. so which is mean difference. So let me put over here. So this is going to be for the case of mean difference. And of course, we have to choose the formula, but the idea is going to be pretty much the same as what we have seen in the previous lecture for the case of mean. Okay, I have three formulas, so I'm going to put this as number 1, number 2, and number 3. So when do you use number 1? So when the value of sigma difference is given, so which is not for this case. So if you refer back to this question over here, so it's nothing telling us about the mean difference of the population. So therefore, so right away we are going to rule out what to call this formula number 1. So we either have formula number 2 or number 3. So should we pick formula number 2 or number 3 for this case? 2 or 3? Any one of you who had actually
Number
attempted?
3.
So that's right. So it's going to be formula number 3. Why is that so, Izurin? Why do you pick formula number 3? For what reason? Can anyone tell me? So why do we pick formula number 3? Because n is less than 30. That's right. So Muhammad Shafiq said that. So the reason is that because of the sample size. That's right. So remember, we only use Z distribution when your sample is greater than or equal to T. So that is when your sample is considered big, 30 and above. But if it's less than 30, so you have to use the T distribution, so which is what happened for this case. So therefore, for this one, I have to use this formula right here. So this is going to be the formula that we're going to use. Why am I deleting that? I am supposed to take a screenshot of that. Okay, so now I'm going to put over here. So this is going to be the formula that we're going to use. And if you notice, all the formulas are going to be in terms of D. So we have X bar D, so it means it's going to be the mean of the difference, standard deviation of the difference, and so on. Okay, and now what we're going to do is you're going to put all these values into your calculator: 6, 3, 1, -5, -8, 4, -1, -2, and you're going to find what is going to be the X bar D and also the SD. I'm not going to do the calculation. I'll let you do it for me. So now use your calculator and find what is going to be X bar D and SD. Or if you have already done the calculation, so let me know what is going to be the value. So if you are kind of shy to speak, you can put it in the text as well, in the text message. I actually read that. So in the chat column, I don't mind. So 2.75, is that for the mean or the X bar? 2.75 for the X bar. So Zurin said that she got 2.75 for the X bar. Anyone got the same answer? You guys know how to use the calculator, right? So the test is going to be next week. You should be able to know well. And you have like 7 questions to answer in 2 hours. So you better be very quick. So you got 2.75, okay. So X bar is good equal 2.75. What about this standard deviation then? What about the SD value? What do you got for the SD?
$3.6154.
3.6154. Is that right? Why do I get a different value for this? Hold on, let me check this. Because I actually got 1.75 instead, but two people actually got the same. So I got 6, 3, 1, -5, 8, 4, -1, and also -2. So when I choose 5 and the mean X bar, I actually got a value of 1.75.
Yes, me same.
Okay, yeah, I actually got a value of 1.75. So that is going to be for the X bar. So I'm not sure how did you do your calculation. And in terms of the standard deviation, so this is going to be standard deviation for sample. So it's going to be 4.3342. So those are the values that I get. And how do we know that these are going to be sample? If the question doesn't write about this being sample, but if data are given like this, automatically we know that this is going to be sample. So it's not going to be population if it's written in terms of data like this, even if the question doesn't mention. Okay, so those are going to be my two values. So what I'm going to do is, so I already have this, but I also need to find the t distribution value. So for this case, I'm going to find a t alpha over 2. So what is my alpha value for this case, for the whole scenario? Alpha is going to equal. What is my alpha value? So anyone going to tell me what is the alpha value for this case? So I have 94% confidence interval. So I'm going to have 1 minus 0.94. So that is going to equal 0.06. So therefore, so my alpha is going to equal 0.06. But according to the formula, we don't want alpha, but in fact, we want alpha over 2. So when this value I divide it by 2, I will end up getting alpha over 2, a value of 0.03. And that's new right here. And according to the formula, so what is going to be the new? So the new is going to be defined, or it doesn't put over here. Yeah, this is going to be our new. So new is going to be defined as being n minus 1. For this case, what happened is that our n value is equal 8. We have 8 sample. So n minus 1, that is going to equal 7. So t, how do you find this? I have shown this to you before. So this is definitely going to be in the statistical table. So the value for this is going to equal 2.2409. So that is going to be the t distribution value. So now that I have all the values, I can simply substitute in here. So now I'm going to have x bar d that is going to equal 1.75. So I'm going to put plus or minus because I don't want to write them separately. I'm too lazy to do that. So I'm just going to put plus and minus. And t is given by 2.2409. So my standard deviation is going to be 4.3342. And that is going to be over square root of 8 because our value of n is equal 8. Okay, so now all we have to do is, now that I have actually put together the plus and minus, so at the back is always going to be the minus 1, okay? So please calculate for me what value do you get out of this? So anyone who have done this already? So what is going to be the lower bound for this case?
Negative 1.688.
Negative 1.6839.
39.
So that's going to be the lower bound. Okay, what about when you put it plus then? So when you use your calculator, you actually don't have to key in twice. Like after you get the answer, go back to the screen, change the negative to plus. You will get the answer right away. So what about the upper bound?
5.1839.
Okay, it's going to be 5.1839. Okay, now when you have a confidence interval and we're talking about mean, so there should be a unit for this. So just to make sure that no one is actually slipping over here, I'm going to pick someone randomly because I noticed that only the same people is talking here. I would like to know what is going to be the unit for this confidence interval. So I have confidence interval over here already. I wanted to know the unit. So Isaac Farhan, can you tell me what is going to be the unit for my confidence interval? So if you don't if you have trouble to unmute yourself, just simply write it on the chat box. I will read that. So there's somebody called Isaac Farhan here. So I want to know what is going to be the unit for this. Isaac, can you tell me the unit for the confidence interval? So is this guy slipping during my class? I don't make it compulsory to do for this class. I don't even take attendance. But when you're here, I expect you to cooperate. So Alf, just don't bother coming. So it's going to be, if you notice over here, it says that the distance in 1,000 kilometers. So it says over here, this is going to be in terms of 1,000 kilometers. Okay, so that is going to be in terms of the unit.
Oh, if we write km only, wrong
No, sebabnya, alright, so let's say kalau you kata dia adalah km, so benda ni sepatutnya this 5, dia bukan 5 kilometer tau. But this is going to be in terms of 5,000 kilometer, 5,000 kilometer. So it's going to be a wrong interpretation. Sebabnya dalam soalan dia dah mention. So the numbers over here, dia adalah in 1,000 kilometers. So this 45, it's not 45 km, but in fact it's 45,000 kilometers. So you have to use the correct unit for it. Okay, and then under here, so it says calculate the estimation error made in the estimation made in Mark 1. So how do you calculate for estimation error? So that is a formula over here. So the fact that, so I'm put over here, our interval width, okay, the width of the interval is actually 2 times the E. So E stands for the estimation error. Okay, so now we wanted to find what is going to be the estimation error. So estimation error is actually the width, so divide by 2. So if you come across question in the test that says that tell you find the estimation error, so this is how it's done. So it's going to be error is going to equal the interval width divided by 2. But then again, so how do we calculate the width for a confidence interval? So if I have a confidence interval with a lower limit A and upper limit B, so how do I find the width of this? So the width is going to equal what? What is going to be the width?
B minus A.
Exactly. So it's going to be B minus A. So it's going to be the upper bound minus the lower bound. And for this case, what is our value of A? So it's going to be this is our A and this is our B. So using information, so just have the substitute. So this is going to equal 5.1839. So according to the value that we get, minus negative on what of 1.6839. So divide by 2. And if you use your calculator for this, so you will get a value of, so what's the value here? So it's going to be about 3.4339. But again, so what is going to be the unit? So the unit is going to be in terms of 1,000 kilometers. That is going to be our error. Okay. So all you have to do is, in order to find the width, just take the upper bound minus the value of lower bound and divide that by 2. So that is going to be your estimation error. And this is general for all confidence interval, not just for mean, but for mean, for proportion, for variance. So if the question asks you for estimation error, so this is how it's done. Okay, so that is going to be for the first question. Then I have another problem over here. So it says the length of a steel bar. So we're actually calculating a length of steel bar. So that is what we are, that is what the data is about. So this is going to be length of steel bar was affected by the heat treatment technique. There are 2 heat treatment techniques used in the study. So we use 2 different treatment, so which is called as treatment 1 and treatment 2. So the length of steel bars based on this 2 treatment was recorded in table 3. So obviously we have 2 populations over here. So first we have the population that comes from using treatment 1, and then we have another population that comes from using treatment 2. And what is the sample size for the first treatment? So we have a sample size of 2, 4, 6, 8, 10. So it's going to be 10. And even for the second one, so we have 10 sample for treatment 2. So it says over here, identify the variable used in the study. What is the variable that is used in the study? Anyone tell me? So what is the variable?
The length of the steel bar.
Length of
Exactly.
the steel bar.
All right, that's right. So what is variable? So variable is actually what data we collect. So what data we collect. For this case, we are collecting data on length of steel bar. So that is why our variable is going to be length of steel bar. Okay, so that will give you 1 mark for just mentioning that. And then you're going to find the mean and standard deviation for both treatments. So treatment number 1. So what is, let me put it over here. So I'm going to have treatment number 1 and also treatment number 2. And for each of them, so we have to find what is going to be the mean, because this is sample. So we're going to use X bar as the symbol for the mean. And for standard deviation, we're going to symbol of S. So find for me. So what is going to be the mean and standard deviation for treatment number 1?
154.8.
154.8. What about the S?
3.0111.
3.0111. So that's 3 1 dekat belakang.
Yes.
Okay. So your friend over here got a value of 154.8 for treatment number 1, and for the case of treatment number 2, for X bar, and for S, he got a value of 3.0111. Okay, so for question for treatment number 2, so what is going to be the mean and standard deviation?
One five two point eight.
152.8.
0.8?
152.8.
Okay, 152.8. What about the standard deviation?
2.6162.
Okay, so that is going to equal 2.6162. So those are going to be the values of the mean and standard deviation for both of the treatment. Okay, so next the questions over here. By assuming the population variance for both treatment are equal, so this is a very important assumption because this is going to decide what formula that we're going to use. So now the population variance for both treatments are equal. Construct a one-sided lower bound. So now I want you to observe this very carefully. We don't want a confidence interval with lower and upper bound, but we wanted construct a one-sided lower bound of a 97% confidence interval of the difference in population mean for treatment 2 and treatment 1. So basically, this is, if you noticed previously, I used the term mean difference for mu d, but now this is going to be difference in population mean. So this is actually the case of independent sample, and I wanted to find what is going to be mu2 minus mu1 because it's mentioned over here. So treatment 2 and treatment 1. So that is going to be treatment 2 minus treatment 1. Okay, now let's have a look at the formula and bear in mind so that the condition is that both population variance are equal and that we have a sample size of 10 and also 10. So now let's have a look at statistical table. So where is the case of independent, what do you call that? For the case of independent sample, for the case of independent sample, so which is the one that I highlighted in yellow over here. So we have altogether 5 formulas. So this formula number 1, number 2, number 3. So under here we have number 4, and on the next page we have number 5. So first of all, what you have to consider is going to be the same idea as previously. Is sigma given in this case? So we have no information about sigma. So we only have the sample given. So therefore, it's definitely not going to be what do you call this? Theorem number 1, formula number 1. And the case about formula number 2 and number 3 is that you are going to use this when the sigma are unequal. So this is going to be the case when the population variance are unequal. Okay, and what happened is population variance are equal, then it's going to be either formula number 4 or 5. So this is going to be the case when population variance are equal. So which is what written in our case. So it says over here, assuming that population variance for both treatment are equal. So that is why. So the only choice that we had would be number 4 or number 5. And the idea is going to be the same as what we have seen before. If the sample size is considered big, so we're going to use the Z distribution. If the sample size fall as being small, so we are going to use the T distribution. And of course, for this case, what happened is that, so we have two sample, for which these two sample size are just 10 and 10. So therefore, it's going to be considered as being small. So therefore, for this case, we're going to use formula number 5. So let me copy this formula. Okay, let's just put it here. So we know that what we're going to need later. Right, so according to the formula, so I'm going to need my x1 bar and x2 bar. So we already have this information. So from the previous question, so we need to find what is going to be T alpha over 2 nu. Okay, so now T alpha over 2. So what is going to be our alpha value? So now we wanted to find 97% confidence interval. So meaning that, so 1 minus alpha is going to be 0.97. So our alpha value is going to be 0.03. But for this case, should I divide by 2 for this case? Our alpha value?
No.
No.
Why?
No.
One
Side
sided.
lower bound.
Okay, exactly. Because here, so we don't want the conventional lower bound and upper bound, but we only wanted a one-sided lower bound. Okay, for the case of one-sided, we're still going to use the same formula, so which is going to be either of these 5, but the only difference is that we don't have to divide our alpha by 2. So that is why here, so I'm going to correct this a little bit. So here we are not going to use T alpha over 2, but we're going to use T alpha. And of course, because we wanted a lower bound, so it should not be a plus, it should only be a minus. So I'm going to find what is going to be for this case. I need to find what is going to be T 0.03. So that is going to be the alpha. So let me write in detail over here so you can know it later. So this is going to be T alpha nu only. The reason is that because we wanted one-sided. So we need to find what is T 0.03 and nu. So what is going to be our value of nu? So according to the formula, so the nu that we need to find is going to be N1 plus N2 minus 2. And of course, for this case, so what is going to be the value? What's my new value for this one?
18.
So it's going to be 18, that's right, because my N1 is equal 10. So I'm going to have N1 minus N plus N2 minus 2. So that is going to equal 10 plus 10 minus 2. And that will give us a value of 18. And you can find this in the table. So when you have T 0.0318, so the table is going to give you a value of 2.0071. So if I'm mistaken, please let me know. So if you have already calculated that. Okay, so now that we already have T, so we are done with one more component. But now, so there is something over here, so which is called as the pooled variance, and the symbol is going to be SP. And before we find the lower bound, so we need to find the SP as well. So where would we get the formula of SP? So it's here, under here. So all I have to do is copy it down. So this is going to be the formula for SP. So the difference is a bit complicated compared to the other ones. No, this is the previous formula. I don't want that. Okay, so this is going to be my pool variance formula. So according to the formula, I only need a couple of things that we already figured out in the function. So I only need to find what is going to be the N1, the N2, and also the variances. So that is all. So when I write it down, so what is going to be the SP? So SP is going to equal square root of, let's put a big square root. So my N1 is going to equal 10 minus 1. So S1 square is going to equal 3.0111 square So, and on this side, I'm going to have the same 10 minus 1, and S is going to be 2.6162 square, and that will be divided by 10 plus 10 minus 2. For those who already attempted this, what value do you get for the SP?
.8206.
Okay, so you got a value of 2.8206. So that is going to be the value of SP. So now that we have all the components, then we can start putting together our lower bound. Okay, for this case that we wanted a one-sided lower bound, so all we need is going to be the lower bound. And what is going to be the upper bound for this case? What is the upper bound value, since we are only going to find the lower bound?
Infinity.
Exactly. So the upper bound is going to be infinity. Okay, so now we're going to find what is going to be the value of A. So I'm going to put according to the formula here. So first x1, so let me put in here. So x1 bar, so that is going to equal a value of, remember, so the thing here is that the question asks you to find mu2 minus mu1. So I have to change the formula. So instead of x bar 1 minus x bar 2, so I'm going to start with x bar 2. Okay, because this is what required by the question. So it's going to be 152.8 minus 154.8. So because it's lower bound, it's going to be minus. So I'm going to have SP, so which is given by 2.8206. And that is going to be multiplied by 1 over 10 plus 1 over 10. And the upper bound is going to be infinity. Okay, what value do you get for that?
Negative 3.26.
Negative 3.26.
1.
1. And what about the other number? Is 0?
4. 4.
4. Infinity. So anyone got the same value? So 3.2614 infinity. Because that's a bit different from the value that I got.
I got different.
Yeah, actually, I missed out one value. So this
0
your value must have.
0.7386. Is it?
I don't think so. No. So I actually missed out one value over here. So I put the SP and this, but I missed out my T alpha. So actually, there should be 2.0071 right here. So you have to calculate that again.
Miss, the 2.0071 you took from the table, right?
Yeah, from the T. So you take it from here. So this is going to be T distribution. So it's going to be on what page? So this is going to be on page. What page is this? 37.
I think it's a different value.
0.0318. It's different value.
Oh yeah, yeah, sorry.
Okay. Yeah, I actually missed out the values 2.0071 just now. So we have to calculate that again. So this is going to be a different value then.
That'll be 4.5318.
Negative 4.5318, and the upper bound is going to be infinity. Okay, so however, remember, every time we write down the confidence interval, so we need to write down the unit as well. So here we are talking about the length, and what's the unit of the length? So it's going to be in inch. So therefore here, so you have to write, so this is going to be in terms of inch. So that's it. Okay, so the thing is that first, when it comes to confidence interval, so you have to know what formula do you have to use. So that is going to be the most important thing. So when you use the wrong formula, automatically I couldn't give you any marks. I can only give you marks for finding this. So this is the only mark that you will get. So other than that, you won't get value for the calculation because you totally get the formula wrong. And secondly, you have to be careful about this. If you notice right here, so the question asks you to find the difference for treatment 2 and treatment 1, meaning that you have to find treatment 2 minus treatment 1. So if you do that differently, so if you put mu1 minus mu2, automatically that your answer is going to be switch the other way around. I can only give you method marks. For example, if you are supposed to get 5 marks, I only can give you 2 for that. So it's such a waste, all right? So be careful and please read the question until the end. So the problem with students is that, so they refuse to read. I don't know why. Okay, so this is question number 4. It's very conceptual, and I really wanted to stress this to you, that for the test next week, so please make sure that you know every single concept. So because it's an online test, so compared to the previous semesters, we actually make it straightforward. This time you have to read the question very carefully, and like there are going to be a lot of conceptual questions. So therefore you have to be strong in terms of that. So for question number 4, it says, what is the effect on the width of the confidence interval in 3? So when the sample size is increased. So now the question asks you what happened when we increase the sample size. So that is going to be our n. So let's have a look at the formula. So let me copy this formula again. No, I couldn't. So we're using formula number 5, isn't it? And I actually expected, because nobody actually told me about this, I actually expected that all of you already have the statistical table. But if any of you actually don't have one and you need it for the test, let me know so we can arrange a way for you to get it. But text me personally for that. Okay, so now, if you remember in mathematical, mathematical equation. So let me give you a very simple mathematics equation. So let's say if I have an equation of y equal x over y. Sorry, it's going to be x over z. So let's say it's going to be x over a. So there are two relationships. So the first relationship is called as being directly proportional. So that's the wrong spelling. So directly proportional. So what is a directly proportional relationship? It means that, so when the variable increase, so y is going to increase as well. For this case, y and x, they are directly proportional. So when x increase, automatically y is also going to increase. And there are going to be another relationship, which is called as being inversely proportional. So inversely proportional, it's going to be the other way around. So like a over here. So what happens is that when the value of a increase, the value of y is going to decrease. So how do you tell whether it's going to be directly proportional or is it going to be inversely proportional? So that can easily be tell by just the position. So if the variable is positioned on top, so it's going to be directly proportional. If the variable is positioned at the bottom, so that is going to be inversely proportional. So if you have a look at the confidence interval over here, so let's say if I put like, this is going to be my y, the value that you get from the confidence interval. So what is going to be the relationship between y and also n? Are they going to be directly proportional or are they going to be inversely proportional? So which one?
Inverse.
Okay, inverse. Okay, that's right. So they are going to be inversely proportional. So that is why what happened for this case is that, so when the value of n increase, so the width, so this is going to be the error. So actually this is going to be our error, whatever that goes behind the plus and the minus. So this is going to be the error. So this is our error that we calculated before. And y is not the whole thing. So y is actually the error. I'm looking for my eraser. So this is going to be y. Okay, and what is the relationship between y and n? So they are inversely proportional. So what happens is that when I increase the value of n, my value of y, so which is actually the error, so the error is going to decrease. So it says over here, what is the effect on the width of the confidence interval? So width actually represent error. So the smaller the width, the smaller the error. Okay, smaller width, represent smaller error. So that is why for this case, so when we increase the number of n, so what happened to your confidence interval? So the width is going to decrease because it's going to be the same as the error. So when error decrease, so width is going to decrease as well. Okay, so all you have to do is you have a look at the relationship between that particular variable and the equation itself. Okay, so that is going to be in terms of the effect of sample size and so on. Okay, I'm going to discuss, I think this should be the last question that we're going to discuss together. The rest, I'm just going to give you the answer and please attempt that on your own. And I did mention this to you before, if you don't attempt it before class, then like during class, it's not going to be easy for you to understand everything because I have to go through things very quickly. Okay, so this is going to be on proportion. So it says a survey was conducted to get the public opinion on increasing the highway speed limit to 120 kilometers per hour. So in Pekan Highway now, so the highway speed limit is actually 90. So we wanted to increase that to 120. So a random sample of 500 adult residents in Pekan. So this is going to be our first people that we sample from. So which is 500 adult resident in Pekan. Shows that 115 residents agreed to increase the highway limit. So 115 residents agree. So while another sample of 400 adult residents in Gambang, so found that 80% disagree to increase. So that is a contradiction over here. So for the first information, they give the number of people who agree, but for the second information, they give the number of people who disagree. So this is how the question can actually trick you. So read the question very carefully. So question number 1, it says find a one-sided lower bound. So again, so this is one-sided lower bound. So alpha, so you don't have to divide it by 2. So it's simply going to be alpha. So it says for the 90% confidence interval on the true proportion. So what are we going to test on now? So we're going to find 90% confidence interval on true proportion, and proportion stand for P. Sometimes the question, it doesn't say proportion, but it asks you to find the percentage. So whether it's used the term percentage or proportion, so it's going to be the same. So we are going to find the confidence interval for P. So of Pekan residents, so we wanted the Pekan resident who agreed to increase the highway limit. So first of all, so we're going to find the P. So what is going to be the P now? So my P is going to be the proportion of Pekan residents who agreed to increase the limit. Okay, so now let's read information about the Pekan people. So I have how many people in the sample? So I have 500 adult, and how many do that agree? So 115 actually agreed. So therefore, the proportion of people who agreed in Pekan is going to be 115 over 500. So what is 115 over 500?
0.23.
0.23. Okay, so that is going to be a value of 0.23. Okay, and now we're going to have a look at the formula. So which formula that we're going to use? So this is going to be in terms of proportion. So for the case of proportion, it is being defined by pi. We use the pi symbol for proportion of population. And the good news is that for the case of proportion, there is only one formula, so which is going to be this one. So all you have to do is take this formula. But then again, remember, so we want a one-sided confidence interval. Okay, so I'm going to paste the formula over here. Okay, so we wanted the lower bound or upper bound. So according to what we have over here, so we wanted a one-sided lower bound. So we're not going to take this part. And for the case of proportion, so proportion is actually probability. So what is going to be the lowest value for probability? What is the lowest possible value for probability? Can anyone tell me?
Negative infinity.
It cannot be negative infinity. So
Zero.
probability means, yeah, probability is chance. Like how many percentage of chance is going to happen? Could we have negative percentage of chance?
No, we don't.
No. So the minimum is going to be
0.
0. So the minimum value is going to be 0. Okay, 0. And what is going to be the highest probability?
100.
Yeah,
100.
it's going to be 100. It's going to be 100%. So if we assure 100% something is going to happen, So 100%, when I convert this to be in terms of like decimal, okay, for example, if we have 90%, so this is going to be 0.9. But 100% means it's going to be 1. So that is why when we're talking about proportion, so the lowest value is 0 and the highest point is going to be 1. So that is why for the case of this one, so we are going to put 1 as the upper bound. So it's not going to be infinity, but it's going to be a value of 1, because chance, it cannot be a value of infinity. We cannot say that, oh, we have infinity chance. No, like the highest will be 100% chance. So that's going to happen for sure. Okay, and then again, of course, when we are using one-sided, so we don't have to divide the alpha by 2. So it's simply going to be z of alpha. And of course, so first of all, I'm going to find, I'm using z distribution over here. And what is going to be the alpha value? So 1 minus 0.9, so that is going to be 0.1. And according to the book, so z 0.1, so that is going to equal 1.2816. So I'm not sure about this, and just copy it down. So if I get it wrong, please let me know. Okay, so now I already have pretty much all the components. All we have to do is substitute back into the formula. So my p-value is going to be 0.23 minus that, which is 1.2816. And I'm going to have a square root of p, so which is going to be 0.23 minus 1.1 minus 0.23 and over n. So which for this case, what is going to be our n? So we're talking about people in Pekan. So that's 500 of them. So it's going to be 500, and all these things are going to be square rooted, and this is going to be 1. Okay, what is going to be my value here? So let me prove here. So what is going to be the lower bound?
Zero point 0.1537.
0.1537. I actually got a different value. Can someone verify if this value is correct or right, or is right or wrong?
I got negative.
No, it's not going to be negative. Remember, proportion cannot be negative.
0.
Oh, sorry, I
0.05.
typed something less. So 0.2059.
Yes.
0.2059. Yeah, I also got the same value. So it's going to be 0.2059, and the upper bound is going to be 1. So those are going to be our lower and upper bound. So that is for the case of one-sided lower bound. So if you notice, for this case, they actually give us two sample. One sample is in Pekan, one sample is in Gambang. But for the first question, they only ask us something got to do with people in Pekan. So you have to read very carefully. And then when it comes to question number 2, then only it says construct a 90% confidence interval. So this will be the keyword. 90% confidence interval on the difference in the true proportion. So this is when we have P1 minus P2. The difference between the proportion of people in Gambang and Pekan. So for both resident in Pekan and Gambang who agree, and now this is going to be, could be the trick as well. So instead of asking people who agree, so the question also could ask for people who disagree. So that could also happen. But for now, so we want people who agree. So we already know from our previous calculation. So I'm going to put PP as a proportion for Pekan. So it's going to be 0.23. But I need to find the proportion of people who agree in Gambang as well. So let me put PG for that. So what proportion of people in Gambang actually agreed to increase the highway limit? Can anyone tell me the limit? For this one, you don't really have to do a calculation. You just have to read the question very carefully. So it will be on the last sentence. So the question says that 400 adult residents in Gambang found that 80% of the residents disagree. So what happened is that, so it's been given over here, 80% disagree. So how many people agree? Exactly. So 20% must have agreed. So therefore, what is going to be the percentage? The percentage 20% is actually 0.2. So for this one, you don't have to do the calculation. So the question itself already give out how many, what is the percentage of people who actually agreed. And when you do the calculation for statistic, anything that is in term of percentage, please change it in term of decimal places. Then only you can proceed with your calculation. Do not use 20%, and put 20 there. No, it should be in term of 0.2 because 20 over 100 is 0.2. Okay, so now we are going to use the formula for difference between proportions. So this is going to be the formula here. So pi 1 minus pi 2. And again, the good news is that when it comes to proportion, there is only one formula. So you don't have to choose anything. So let's copy this. Okay, and for this case, this is no longer one-sided. So we want it both-sided. So therefore, our z is going to be different. So I'm going to have z alpha over 2. So my alpha is 0.1. So I put over here alpha 0.1. So when I divide that by 2, I will get z 0.05. And according to the table, so z 0.05 is going to equal 1.6449. Okay, and now that I have all the information, I can simply put them in here. And again, so you have to be very careful. So how do you know whether it's going to be people in Pekan minus Gambang or Gambang minus Pekan? So you read the question. So it says over here, 90% confidence interval for both resident in Pekan and Gambang. So Pekan comes first, then Gambang. So it means that you can have people proportion in Pekan minus proportion in Gambang. So therefore, I'm going to have Pekan proportion is going to equal 0.23. So minus Gambang proportion is going to equal 0.3. And then plus minus. So that value is going to be 1.6449. So this is going to be a big square root. So let's see if I can actually fit everything in there. So P1 is going to be 0.23 multiplied by 1 minus 0.23. And how many sample in Gambang? So Gambang, I think it's 500 previously. Yeah, it's over 500. And for those in Gambang, so it's going to be 0.2 multiplied by 1 minus 0.2. And I think that we have a sample of 400 in Pekan. So therefore, it's going to be over 400. Okay, and of course, like the lower bound is going to be minus, upper bound is going to be plus. So what value do you get?
Is that the value could be negative?
Yes, I will explain later why this one could be negative.
Okay, so for me, I found the lower boundary is negative 0.0152.
Okay, and the upper bound is?
Wait.
0.0752.
Okay, 0.0752. Okay, when we talk about what do you call the chance of something, like I said, that I tell you before, so the chance could only be from 0% to 100%. So that is when I talk about like one thing, so one proportion. But here what happened is that we talk about two proportions. So two proportions, there could be a difference between them, P1 and P2. Okay, for example, so if the chance for P1 is actually 20%, and the chance for P2 is actually 40%, and if I find the difference between them, of course it's going to be 20 minus 40, and it's going to be negative of 20%. So difference, yeah, it could be negative, but when it comes to one population, one proportion, it cannot be. Okay, so remember pi, so it should strictly be from 0 until 1. But if you have pi 1 minus pi 2, then yeah. So it could be from negative infinity until infinity because we're talking about difference. So it's not restricted to being from 0 until 100. Okay, so I think that's all the time that we have for today. I've actually recorded this. And I really suggested that you actually do these questions. If you haven't do this question, then only listen to the recording and like compare with what you have with what I've written over here. And as usual, so I will fill it in all the all the answers, and I will send it to you so that you can check your calculation is correct or wrong. Again, I would like to remind you, for those of you who still have no access to the statistical table, so please text me personally. I will sort of like we will find a way for you to get it, because when you have tests next week, you have to find the Z value, you have to find the T distribution, like formulas, yeah, it could still be in the slide, but not for the Z and the T test values or the chi-square and such. Okay, so therefore, please make sure you have them, the statistical table. And again, I would like to remind you, so what date is our test, by the way? Does anyone know?
26.
So it's going to be 26? Is it 26 or 27?
Yeah.
Now I'm not sure. Yeah, it's going to be
20.
26. Yeah, it's going to be on 26. So please make sure that you don't have any clash on 26 with another test. And please be prepared. So until what chapter are you going to be assessed? You're going to be assessed until 3.2, hypothesis testing. So that is why for now, for this week, so please go through all these questions that I have compiled. So make sure you understand on confidence interval. So when you come back on next week, so we have class on Tuesday, right? So we're going to have another online class. I'm going to discuss with you chapter 3. So I'm kind of worried about chapter 3 because chapter 3 is like, it could be very, very tricky and you have to read the question carefully in order for you to come up with hypothesis. And if your hypothesis is wrong, automatically your whole calculation is wrong. If you're supposed to get 8 marks, you will only get 2 marks if you get hypothesis wrong. So you have to be very careful. All right, so we will discuss that on Tuesday, and I will try to give the question earlier this time, probably during the weekend, so that you can attempt them. All right, so before we end, anyone have any question regarding anything?
Just until chapter 3.
It's going to be 3.2. Hypothesis testing for mean.
Okay, thank you.
All right.
We don't have a quiz too, ma'am.
We will have quiz too. So I'm actually, I'm still thinking like how we're going to conduct, because I want you to do calculation, but at the same time, I want you to have a different set of questions as well. I don't have, so I'm still thinking, what should I do? Like, how would I try to make the question? So I'll let you know later. So when is going to be quiz 2. And so somebody asked a question on chat over here. So how many questions for the upcoming test? Okay, this is going to be about the test. It's going to be 2 hours, and there will be 7 questions. As I told you, like you can try to do the test problem that is on Kalam. So please try to attempt them so you get the idea of how the question is going to be like. But as mentioned to you before, like your test is going to be different from what you have seen before. So because it's online test, so we actually make it, how do I say it? Like on the concept that there will be calculation, but you have to think a bit in terms of the concept as well. Yes, so you have to read every single word very carefully. Don't skip anything. Anything else? So yeah, the answer is 7. So I'll have 7 questions. Alright, so if you don't have anything, so let's end here for now. So I have recorded this and I'll upload this on YouTube and send you the link. Alright, so I'll see you on Tuesday then. Alright, bye.
Thank you, Miss.
Thank you,
No
madam.
problem.
Thank you, Doctor.
Madam,
No problem.
Thank you, Miss.
saya ada soalan pasal assignment.
Okay.
Saya
Nak
nak
tanya kat
tanya.
sini ke nak text?
Jap.
Aha.
Madam, nak tanya pasal soalan nombor 10 tu, yang part 1. About
Soalan nombor 10 ni suruh buat apa
Box plot, Miss.
Okay,
box
kenapa
plot.
nak box plot?
Box plot tu kan,
Mm-mm.
based on table yang data kita dapat ke based on histogram table yang kita dapat?
Based on Instagram table. Okay, sekarang kita dah bahagikan ikut group kan? Ada 4 group kan?
Ya.
Daripada data tu lah. So setiap group tu akan ada satu box plot.
Maknanya based on sampel lah, sampel kita dapat data. Kalau contoh ada 15 lah ni.
Okay, dekat mana yang kita bahagi kita punya data? Dekat soalan nombor 5 kan? Okay, dekat soalan nombor 5 tu kita bahagikan dia jadi 4 group, betul tak?
Betul.
Okay, so setiap satu group tu lah dia akan jadi satu box plot.
Okay, faham.
So katalah awak buat female dengan male kan. Akan ada satu box plot untuk female yang data kita lebih kecil dari 30, satu lagi untuk data besar, male pun sama.
Okay.
Dah nak hantar dah ni, lusa.
Itu je, tinggal tu je.
Tinggal tu je? Okay, fine lah kalau tinggal tu je.
Okay, thank you, Ida.
Alright, no problem.